In this video, we are going to take a look at some more examples of integration by substitution. So let's jump right into this first one. Here we have the integral of 4x cubed times sine of x to the fourth dx. First thing I would ask myself is, can I integrate that directly? And the answer for me is, I don't see how to integrate that directly without doing a little bit other work. I see a product of functions, one of those functions is a composite function. So that sine of 4x to the fourth is a composite function. So what would happen if we did a u-substitution? So if we said u is equal to, so I'm going to do this over here to the right. If u is equal to x to the fourth, what would the derivative of that be? That would be 4x cubed dx. Well, we have a 4x cubed dx, so we can rewrite this as an integral of sine of u du. Finding the antiderivative of sine, that comes from a negative cosine. And then change back to the original variable, so negative cosine of x to the fourth plus c. So that is our first problem. Great. What about the second problem? So here we're integrating sine of x divided by cosine cubed x dx. Here I might recognize that we have that cosine of x cubed there in the denominator. That is a composite function. Cosine is the inside function, so what would happen if I said u is equal to cosine x? Well, du would be negative sine x dx. We almost have that. We have sine x dx, so I'm just going to tack on a negative here. If I tack that on, that changes the problem, so I'll also put a negative out in front. And so this is equal to the negative of the integral of u to the negative third du. Right, so this portion is the du. Here you have u to the third in the denominator, so that is u to the negative third. Add 1 to the power. Divide by the new power, so dividing by negative 2. So negative 1 over negative 2. So those will just become positives. And so we have 1 over 2 cosine squared x plus c. Great. So that's example 2. Let's move on to example 3. Here we have a definite integral. Here we are integrating 1 over the square root of x times 1 plus the square root of x squared. 1 plus the square root of x squared is a composite function, so I might consider u being equal to 1 plus the square root of x. Square root of x is x to the 1/2. So du is going to be 1/2 x to the negative 1/2 dx. And so this will become an integral of, so we need to pick up a 2 in that denominator, but if we toss a 2 in that denominator, so 1 over 2 square root of x, that's what this is. 1 over 2 square root of x dx. Right. So that's our du, all of that mess. Right there is our du, and we have a u to the negative first. So we have that 2 u to the negative 2 du. Let's go ahead and change our limits of integration here. Again, you could leave them as stars and then just return to the values of x, but I like to change them. So since I'm making the video, that's what we're going to do. If x is 1, then u is 2. If x is 9, then u is 4. So I'm just plugging 1 and 9 in for x right up here. And so 1 plus the square root of 1 gave us 2. 1 plus the square root of 9 gave us 4. And so I'll change the limits of integration to 1 is associated with, becomes the 2, the 9 becomes the 4. Add 1 to the power, divide by the new power. So now we have negative 2 u to the negative first from 2 to 4. And so we have negative 2 over 4 minus a negative 2 over 2. And so we get 1/2. Beautiful. And we have one last example here. Here we have the integral from 0 to pi of sine x plus cosine 2x. Now, how are we going to deal with that? Well, we could split it up as an integral from 0 to pi of sine x dx plus an integral from 0 to pi of cosine of 2x dx. The sine x portion, we should be able to solve that. We can integrate that. That's going to become sine integrates to negative cosine x from 0 to pi. What about the cosine of 2x? Well, on that piece, and that piece alone, we could say u is equal to 2x. Let me do this. So we could say u is equal to 2x. So du is 2 dx. So we're just going to tack on a 2 here and a 1/2 out in front. So we have plus a 1/2, the integral of cosine of u. And here, if x is equal to 0, u is 0. If x is pi, u is 2 pi. So this will become an integral from 0 to 2 pi. So on the first piece, on this piece right here, we have a negative cosine of pi minus a negative cosine of 0. Plus 1/2, and cosine will integrate to sine. And that sine u we are going to evaluate from 0 to 2 pi. So when we do all that and plug all of our stuff in, we are going to have this part right here. Cosine of pi is -1, so we have the negative of -1 is a positive 1, plus cosine of 0 is 1, so 1 plus 1 is 2. When you plug 2 pi in for sine, into our value of sine, sine of 2 pi is 0, sine of 0 is 0. And so we're just going to end up with 2 as an answer there. And that's how we go through and do u-substitution. Come back for our next video, and we will look at some further examples. We will see you there.